Hello, this is Joris Peels with 3D Printing News Unpeeled, courtesy of 3dprint.com. And today on the 3D Printing News, today we're having a little bit of technical problems. Give me a second. Sorry about that. We have a little bit of an issue. Sorry about that. There's something with the intent. So now it should be fine. My name is Joris Peels, and this is another issue of 3D Printing News Unpeeled. And today we're going to be discussing one 3D printing additive manufacturing news item that is more important than all the other news we're going to see today, and that is the proposed acquisition by Nikon, the Japanese imaging, precision manufacturing, medical giant firm that's probably best known for its cameras, but also makes lithography and imaging and 3D scanning equipment, lots of other things. So that firm has offered to buy the outstanding shares of SLM Solutions. And SLM Solutions is a German company that is a powder bed fusion company. It's one of the leading companies in the powder bed fusion market. It's either second or third, and depending on how you would track progress in that market. And overall, this is a momentous thing for 3D printing. This is a really, really big thing, and it showcases some renewed but very patient capital entering into the market. And it really is at a time when we're seeing a real professionalization in the 3D printing market. And so it's very opportune. It's going to be the most talked about news for today. I'm pretty sure we can all agree on that. So what has happened? Nikon has offered to bid 83.7% over a 3-month average of SLM Solutions shares. SLM Solutions at the moment has about a 433 million market cap, and the company is saying that it'll essentially invest and buy the shares, outstanding shares, also some convertible bonds, and increase the share capital of the firm by around 10%. This is a friendly bid in the sense that Elliott investors or Elliott partners and their affiliated companies, who are one of the key investors, ENA Investment Capital and Hans-Joachim Mede, who's one of the founders of the firm, are open to the bid, and the management board and the supervisory board are also open to the bid and welcome it. Nikon CEO Toshikazu Umatate stated, "By acquiring SLM, Nikon is taking an important step towards our Vision 2030. We are focused on digital manufacturing as a growth driver and will create value through the promising market of metal additive manufacturing. Metal additive manufacturing revolutionized mass production by enabling our clients to manufacture highly complex parts, reduce cycle time, carbon emissions, energy costs, and waste. Nikon and SLM share the vision that our technology-driven innovation will transform the future of manufacturing. This acquisition will be key to growing our digital manufacturing business." So first, let's unpick this a little bit, because there's maybe one or two things that are important. One thing that is important is that Nikon is explicitly saying that this will be a product they will sell. So they will put these machines on the market. So if it acquires SLM Solutions, Nikon branded 3D printers will hopefully power our next 3D printed revolution. It's not going to keep this technology for itself, as GE did initially. It's not going to keep the latest developments for itself. It's going to function as we would call an OEM, so an original equipment manufacturer. Also, what I think is, of all the things you could have said on additive, is highly complex parts is the one thing the Nikon CEO takes apart. I think that highly complex assemblies is really one of the key elements that we can do better than other people. Reducing cycle time is, we wouldn't express it like this, and reducing cycle time depends on how you look at it. Reducing time to part is much faster with 3D printing. We can make parts much faster than anyone else can. Cycle times can be much quicker depending on how you would see that part. What I think is notable as well is that he brings up carbon emissions, energy costs, and waste. So this kind of stuff, which a lot of people kind of see as kind of maybe a bit too do-gooderish and cute, is really key to some businesses that are really serious about reducing waste, like operational excellence kind of businesses. And it's also key to how certain kind of companies that are more conscious and more environmentally friendly see their future as well. They don't see being environmentally friendly as being something cuddly. It's something that will give them an edge. The Nikon also says this is part of their 2030 vision. essentially they want to transform into what they call, it's a bit woolly, but the statement is a key technology solutions company in global society where humans and machines co-create seamlessly. And that's their kind of vision. This fits into their much bigger role for additive manufacturing and the much bigger plans for additive manufacturing that they have. So on the whole, I think this is a momentous move, and we're going to unpack this a little bit by bit. So first off, I'll give you my synthesis as in my opinion right now. This is a very good move for Nikon. It's a very, very good move for SLM Solutions, and it's going to be very beneficial for our industry in the long run. So right now, what is the market space, right, for powder bed fusion? So powder bed fusion is a technology that makes metal parts, in this case. It also makes polymer parts, and it's led by a company that does both metal and polymer parts called AOS. AOS is a privately held, family-owned company that is a leader in both polymer, the plastic space, and the metal space. Powder bed fusion, which you with a laser sinter powder, and then the loose powder around it acts as a support and is later discarded and may be reused in some cases. These machines are different than other metal 3D printing technologies. Other metal 3D printing technologies like binder jet may be cheaper, but usually for really fine details, for really fine mechanical things, for things that have to be the highest quality, powder bed fusion is the best technology we have. And it's very good at creating objects for, let's say, 5 centimeters squared to about 30 to 40 centimeters squared. That are, and they have to be mechanical objects or have to be very, have tight tolerances. 3D printing itself, or the powder bed fusion itself, is just one part of the process. We have to take a file, we have to prepare it for 3D printing, we have to design the support strategies, so support materials, support parts have to be created to keep this part from ripping itself apart. And after we're done printing, we have to remove the part from the powder bed. We have to de-stress this part. We have to cut it from the build platform. We have to maybe shot peen it or hip it or CNC it maybe even to get it to be where we need it to be. So 3D printing is just one step out of a multi-stage process that sees a lot of conveyancing, a lot of moving around of parts. At the moment, AOS is the biggest company. SLM Solutions is probably second. It depends on how you count. And then GE Additive is third. Other companies like Velo 3D are quickly seeming to catch up with them. And these are kind of the established players in the market as now. We have other companies like smaller Chinese companies like Xi'an Bright Laser, Farsoon, E Plus 3D. We've got companies like Matsuura and Sodic and DMG Mori, all Japanese companies that play a role in the marketplace. But essentially, up until now, it's been AOS is the leader and everyone else is playing catch up. This has changed recently when SLM Solutions was one of the first firms to successfully go to 12 lasers. So what happened is for a very long time, we were making lab machines that are fine with just one laser or maybe two. Then everyone standardized on quad lasers, right? This meant that that we had a really much higher productivity. You could do some more better quality parts in some cases as well. And the machine utilization was much better as well. So people can really go more to production. But these machines still have a ton of settings. There's still some problems with them, so it's not great. What then happened is SLM Solutions took a big leap and made a 12 laser system. This gives us a lot more complexity. And then other players such as 3D Systems, such as Velo 3D also started to implement more laser systems, which would give them more productivity. But of course, more productivity means more complexity as well in this case, because imagine just running one laser, the code you have to generate from it, the sensor information you need, the settings you need, it's all relatively simple. Now all of a sudden you've got 12 lasers moving around and everything gets really, really complex. So this is the move we're at. At an industry, we've gone from like a fab or lab business to a fab business where we're now being used to make end-use parts, sometimes even structural parts by Airbus and Boeing and also Lockheed. One of the biggest problems here is that we have to qualify parts, we have to get these up and running, and that takes very long. And there are some constraints. The constraints are we can't make very large objects, but the machines per hour is still quite expensive compared to other machines. 30% of the part cost is manual labor, which is basically us carrying around parts and stuff. Then there's additional costs from finishing parts, right? These multiple steps we have to do. Quality assurance is quite complicated for us to do as well. And we don't really understand a lot what goes on in the actual 3D printing process, where this laser meets this powder. There's some irregularities that happen, like spatter or agglomerations of parts coming together. There's a lot of stuff that's happening that basically would require a lot more understanding, a lot more, in some cases, physics, a lot more monitoring to get us to understand what's actually happening. So the process complexity and the machine complexity is far, far higher than we would expect for like a CNC machine, where you just have a really accurate, really sturdy machine cutting away precisely at something. We're building up an object in a heated chamber based on a powder. And between that laser and that powder and that melt pool, there's a lot happening that we really don't understand, if we're being honest. So companies are essentially learning new skills. So people are looking towards AI, they're looking towards software, they're looking towards optimal toolpath. They're looking to better support structures. They're looking at better kind of laser paths and spot sizes and kind of modulating these lasers as we go on. So the device has gone infinitely more complex, right? There used to be 36 settings and a laser, and then it'll be fine. And now you've got 12 lasers, you've got more settings, and you've got much more numbers to crunch, much more data, an unimaginable amount of data that we can now crunch. This also means that the machine itself is getting more complex. When the average price of these machines was 300,000 at one point, it went up to about $1 million. Now we're seeing machines of 3 million or more. So big sticker prices, bigger machines, bigger chambers. So this has to happen in an enclosed chamber that's heated, that has gas in it. That gas costs money per hour, but also that enclosed chamber needs to be very sturdy and very safe as well, because with some of these materials, especially like titanium and stuff, it could explode. So that all means that the actual cost of the machine is going up. So, what's the end point here? What are people working towards? Now, the number of lasers in this, what we call the laser wars at 3dprint.com, is a bit disputed. We think a lot of it is nonsense, and it's just basically kind of like people bidding against each other. But everyone agrees that we need a much higher productivity, and everyone agrees that we need much better yield on machines and much better quality. So where we're ending up is a production cell, an automated production cell, where we're getting a printer that then spits out the parts, and then it'll convey it part to part or step to step to end up, and ultimately an end part automatically without a human being involved leaves the printer and leaves this multi-step production step. Actually, Additive Industries is a small Dutch firm, came up with a kind of this paradigm of doing a lot of handling in the machine and doing this conveyancing the machine as well, to make that whole thing have a lot more process assurance and quality assurance, and just make everything more automated. So that kind of like production cell kind of methodology is where we're going. Now, this is also important because we're starting to use for aerospace parts on aircraft, parts on consumer passenger aircraft, right? So that means we need to process monitor a lot of stuff. We need to CT scan a part. We may need to 3D scan a part several times, or even CT a part maybe multiple times, to make sure that a certain process step didn't damage it internally. So we need complete process assurance or quality assurance throughout the entire process to assure that our parts aren't getting messed up somewhere. And we need these parts to be much higher quality than now, because we're going into rockets and stuff like that. So overall, we mean the investment went up, the machines are more expensive to buy, the machines are much more complex, there's lots more data, and there's going to be lots more software and stuff that need to be applied to solving this problem. And what are the markets we're tackling? Well, one of the biggest ones is commercial aviation, right? The other one is automotive, where we're a bit too expensive for them at the moment, but they're very interested, right? And they're looking more towards binder jet and other less expensive technologies to implement. Then there's orthopedics, where there's millions of 3D printed orthopedic implants that are going to become a reality, up from tens of thousands nowadays. In orthopedic implants, we can give an implant a better surface. We can give it a better modulus, so it just approximates your bone better. And we could, for example, let blood flow better to it, get better osseointegration. So we're actually cheaper at producing medical implants or orthopedic implants than other technologies. And that's an advantage there. So that's a big area. And the other area is the commercial space market. Nearly all commercial space players use 3D printing to make their propulsion systems. That means that they go that the propulsion system is 3D printed because we can get optimal surfaces that other people can't make. Also, we can make these parts faster. We can go from a design to a final part faster, and we can iterate faster. So for these companies that are trying to race to the moon or Mars or beyond, we're a key technology because we can let them innovate faster. We can also let them integrate components. So they're taking 80 components, making 3, which will make them like be able to change that component much more quickly, and less assembly. There's less storage. There's all sorts of advantages to doing this. So for these kind of guys, we're key technology. And also, yeah, we can make internal surfaces and lattices and other structures to get a better part, right? And generally, we can make lightweight parts, which is very important if we're making a rocket, obviously. So this is a huge market, not only space propulsion, but look at something like satellites. It's a market that some people say is going to grow by 4,500%. On a satellite, your launch costs are like 10K per kilo or something. You know, it's very easy for us to save you 40% of the weight of your part on a structural part. And that immediately on a satellite will pay for itself. And then if we go forward, we're going to need to in-space repair things, longer missions and moon bases and stuff is also going to be a huge, but that's way into the future. That's also going to be great for 3D printing because you're not going to be able to bring all your tools or all your things with you, but you may be able to 3D print them on location. Now, on top of that, there's a huge burgeoning military market consisting of Lockheed, Northrop, Honeywell, and Raytheon using 3D printing in drones extensively, using 3D printing for missiles, munitions, and also in all sorts of different optimized, weight optimized components. This is also driving the quality and cost curve to come down, and something is going to kind of semi-unite the space industry and these defense industry that are two of our biggest options, and that is hypersonics. And a hypersonic craft is a craft that goes over 5 times the speed of sound, and that, of course, has to be super weight optimized because the materials are going to be expensive. Any kilo you put on that thing is going to be super expensive because of the kind of forces it has to be subject to. So that's kind of what's going on in our market. So we've got what's really driving growth right now is space, right, and orthopedics, and what's in the interest, you know, we could get more from or more business from is automotive, satellites, and then later on a much more military stuff as well. So for all of these things, we're going to need to up our game in the quality. We're going to have to automate more. Now, there's also a 3D printing service market. Now, a service market used to be a guy with maybe 5 to 10 employees. He had one machine. He paid $1 million for it, about $2 million to install it, and he was trying to make that machine work. It's a very difficult way to make money, actually. Now what we're seeing is the emergence of companies like Syntavia, which is a company in Florida-based service that is really specialized in defense stuff and satellites and all that. Beehive 3D is trying to do the same thing. More 3D, which was acquired at Nikon, we will return to that later, is also doing the same thing for aerospace components and defense. There's Kozlowski Additive Manufacturing, also doing the same thing. And then we have ADMAN as well. These service bureaus are really set up to be the leaders in quality. So a lot of people expected the service bureau industry in 3D printing to consolidate. It's happening. We'll get to that as well. But what's also happening is we're getting some quality leaders to say, us 5, let's say, ADMAN, CAM, More 3D, Beehive, Syntavia are the only people that can do this. Right? And we're the only people that can make your satellite part or make your missile part and that kind of thing. And these guys are going to get these big government contracts, especially as more money pours into hypersonics. Now, specifically for space and these kind of crafts, these guys need highly automated, highly accurate machines capable of making big parts. So they are going to cheer on any kind of large 12 laser machine, and they're going to jump all over each other to buy them. Then we have companies that are in the kind of like the automotive business, like Divergent, Azoth, GKN. They need to deal with a cost structure where the automotive company is saying, I'd pay you $4 for that part, right? And we're saying we could make it for you for 100, right? And these guys want automation as well. Azoth is making car parts right now using 3D printing, but they've turned to binder jet because that's just a cheaper technology for them. Divergent is making hypercars and assemblies for other car manufacturers, Zinger cars, and for car manufacturers like Aston Martin, and they're making all sorts of new structures and things using powder bed fusion. But they need better economics because they're dealing with these car things. And okay, Aston Martin for 10 cars in a small series is okay. But if they really want to get much bigger, and if they want to go into like Porsche or something like that, or Cadillac or whatever, then I think it's going to be a lot more difficult for them to deal with the current cost structure. And then GKN is a large company that's doing a lot of automotive components as well. They really want to reduce cost. But they are looking at it from an industrial process. Oerlikon is as well trying to do this, but then for aerospace. Then we do have actual consolidation in the 3D printing market as well. That Prototech is acquiring a whole bunch of firms. It's basically a roll-up strategy for additive manufacturing services. Core is doing the same thing, right? Then we have two or a couple of publicly funded companies, Proto Labs and Xometry, most notably, they're trying to raise capital and grow like hell on the stock market. So these guys are all consolidating the market, but maybe not in the way that you would assume. They're consolidating the market in a quality cluster, an automotive cluster, and kind of a volume cluster, right? The automotive cluster wants to make parts that are cheap and high volume, right? And the defense / aerospace cluster wants to make parts that are large and really high quality. So essentially they're getting different desires, but all these guys want higher quality and higher yield and less errors and more automation, which means that machines will get more expensive, driven by these kind of customers. Think about this kind of as the same approach as like certain airlines pressuring for the A380, even though most people don't like it. Emirates loves it because of the way Emirates is set up, and Emirates wants the A380 to exist because it really fits into its gigantic centralized hub and spoke type of thing that it's doing. So this is the landscape as succinctly as I can bring it to you today. So what does that mean? That means that the complexity of the machines is going to increase, quality needs to be better, and we're going to need a lot more investment. So this is why I think Nikon is a fantastic partner. It's absolutely fantastic. They've got a lot of metrology experience. They do a lot of scanning. They do a lot of metrology generally. They sell metrology equipment. They do a lot of CT scanning for internal parts, which we use as well to check that the part isn't broken inside. So all of that knowledge and all these machines that Nikon makes will really, really fit well into that offering. And if we're looking at making a 3D printing production cell, a lot of other Nikon equipment will play a role in this, right? Now, Nikon also has really deep chip-based and also non-chip-based and lithography-based optics experience, right? So this means that it could really use its optics experience to improve the lasers, improve how the material is handled, and improve things like density and speed. They also make lithography. They make chips, and this is a really, really high quality process. One of the most difficult things that humankind does, and the level of process control and accuracy they need, plus all things like motion stages and all the stuff, the control they need there, is going to be very, very valuable to them. And the other thing is that Nikon has access to money, more money than other people do. And so this is, I think, a really good move for Nikon, and I think a really good partner for SLM if you're looking at it from an SLM Solutions point of view. For SLM Solutions shareholders, the company was worth more years ago, but it seems like it's a fair premium, and it values the company kind of like similar to where it was at its height. So, and you know, the going is going to get more tougher. They're going to have to dilute their shares or take a hit for a couple of years or be really patient for another decade. So I think for them, this is a really good deal as well. I think this allows them to get out at a premium right now. It allows them to get a good return in a lot of cases, and I think it's great. Now, this is also a great investment for Team Japan. Japan has been completely aloof to 3D printing, to be honest. Out of all the larger companies and all the manufacturing companies, they've really done the least in 3D printing. Sony actually was a really early company that commercialized stereolithography, but they left the market right when it was getting to be interesting. How different things would have been, by the way, if Sony would have been in it. But now, DMG Mori has a number of machines, like about 5 different machines, but they're not really growing very quickly in their installed base. We've got Sodec and Matsuura, who also have some deployed hybrid machines, also not growing very quickly. There's some Japanese e-beam machines coming out as well. So the country is there, but Germany is far ahead of them, the United States is far ahead of them, and even China is far ahead of them at this point. In industry and the types of things they're doing, the types of parts they're making for aerospace, for example, China's ahead of Japan. So I think for Team Japan, if you will, this is an incredibly good move because it puts them in the driving seat once again, and it can really do a lot of great things for Japanese companies. So other players. Now, one other thing is Renishaw has been for sale for a while. We're not sure what this means for Renishaw. It could mean that Canon or other players will be more interested in buying Renishaw. But it also means that Nikon looked at this market and decided to pass on Renishaw. This is not a good thing for Renishaw in that sense. Renishaw has a lot of metrology type of stuff as well. So it's, that's not great. So, but it could lead to more people taking a look at them and more companies, like maybe even companies a little further afield, like China's Medea and other companies trying to take a look-see. For GE Additive, this means that that they'll need more money. They will need more money to advance to more complicated, more higher quality, more robust 3D printers. So GE is going to either take another look at this or not. Is GE Additive its own unit that's going to revolutionize the whole world's manufacturing? Is it a unit that is going to revolutionize GE internally? It looked much more the case when GE had a lot more investment in power and rail and stuff. GE Additive's businesses in the company could be so good for making lighter weight, better rail engines and things that it doesn't really need to focus on revenue or getting out there. But now with the slimmed down GE, GE Additive is going to have to really get customers and grow the business as an OEM. So this means that GE itself has to make a strategic decision whether to go on with this, or perhaps even sell the unit, or perhaps even do something like this. We know that those are the options. Now for AOS, what does this mean? AOS has 100% of the shares. They have lots and lots of financing opportunities. The family, the Longer family, has a long-term vision. They're very patient. They're very, very smart. So they'll look at this as kind of like in a longer term view. But the company does have to, of course, make this big investment path to catching up. So does this mean that they collaborate with Zeiss, who has bought some 3D printing investments? Zeiss is a German company. Zeiss was an early, long-time AOS investor. Hopefully they're okay with that now. So on the whole, does that mean that AOS is going to partner with Zeiss, for example? Or are they going to strategically partner with Siemens, for example, to make a Siemens-based? Or maybe even sell the company because it needs so much more extra investment to get up there? Or is AOS going to just bide its time and go straight ahead? I'm not sure. Probably they're going to go for the bide its time, but I think that Zeiss and Siemens are both really interesting options for AOS to work with. And also one could think of a partnership kind of thing between Zeiss, Siemens, and AOS to really make a manufacturing solution that is kind of Team Germany's effort here. Additive Industries got the vision right and had the machine that integrated a lot of these production steps. Now it looks like the small independent company that's backed by a family investment fund will need a lot more capital to really grow. So will it sell itself to Canon, for example? Is it able to double up? Is it able to get the next investment? Could it sell itself maybe to Siemens? Right? DMG Mori, on the other hand, is quite small. Does it see this as a great thing? Is it going to work together with Nikon to produce these production cells using DMG Mori equipment, for example? Is DMG Mori going to get powder bed fusion machines from SLM? And then Nikon will work on the hybrid machines and the other technologies with DMG. That's kind of like a very exciting possibility. I think I think they'll have some nice meetings in a very, very nice restaurant about this soon. Again, from Matsuura and Sodic, this is also the same thing. They could maybe make production cells together with Nikon, or maybe at the same time they could kind of feel themselves be pushed out here, or this could be a renewed interest and vibrance in the Japanese industry and really inject a lot of money and excitement into Japanese 3D printing. If we're looking at the Chinese companies, mainly these are E+, 3D, BLT or Xi'an Bright Laser, and Farsoon. Those are the most notable Chinese companies. All three of them have moved overseas and are really trying to expand. They also have quite large machines as well as rather inexpensive ones. Now, for these companies, it's going to become more difficult now for them to penetrate the Japanese market specifically. It's going to be more difficult for them to have to come up with this integrated kind of solution as well. So for them, it may make it more difficult, or it would mean that they will now focus much more on kind of entry-level machines for dental and for other kind of 3D printing applications. So for them, it would be very difficult. There's more skepticism now towards Chinese companies because of a lot of things, and especially in defense and other kind of tightly controlled market. There's a kind of make in America kind of manufacturing push as well. So the Chinese players are probably, going to be less interested in this move than some of the other guys because they're really grappling with these geopolitical concerns and also just breaking open a market. HP, on the other hand, it gives, on the one hand, some more credibility to their market. They look like they're first in the water as one of the large imaging companies. It gives credibility to their 3D printing push. It puts more pressure on Ramon Pastor and all the metal 3D printing guys to make their binder jet solution more active in the market quicker. And but it does validate their whole approach. So I think for them, it's a good news, and it puts them up against companies they know and love well. Let's say so. This is, I think, it could be a good impetus for the company. Again, no one really is going to want to shop for a binder jet machine and then come home with like a ALSM 290 or something. It's very different things. But from investors, I think a lot of them will look at this in a very, very different way. Again, it also validates Desktop Metal. It validates their growth plans and what they've been claiming all along. And even though, again, they're a binder jet company, it does kind of like say, hey, look, this market is alive. This is happening, and this is a revolution. Mark IVs as well, they acquired Digital Metal, a industrial binder jet company, so it looks like it validates their approach and their industrialization from the ground up kind of approach through bound metal and then now binder jet technologies as well. For 3D Systems, it's going to put more pressure on 3D Systems' own multi-laser development. But again, it also will make the U.S. Government and the defense community look harder at, okay, what options do we have of nationally made 3D printers in the United States of America? Are we going to get them only from 3D Systems metal printers? Are we only going to get them from 3D Systems and GE? Or do we now also get them from Nikon? Is that okay for us? So that's going to be very interesting, and that's going to really depend on a lot of contracts from them are going to depend on this. For Surratt, Vulcan Forms, and Velo3D, I think the challenge is the same. Nothing really changes for them. I mean, they knew already what they were going to have to do. The numbers just got bigger. They're either going to have to get more financing, they're going to have to grow even faster. The challenge just got incrementally bigger, but they knew already what was going to happen. They knew already what the landscape was. So I don't think it changes much for them. For Stratasys, their polymer-only strategy right now means they're kind of like absent from this. Does that mean that at one point the people will identify the polymer 3D printing market as a backwater while the metal 3D printing is where all the excitement is? That's a risk to them from a corporate development kind of like standpoint. And apart from that, it doesn't really have any impact on them at the moment. So on the whole, what are we thinking here? That, in my opinion, is a great move for Nikon. It's a great move for SLM Solutions as a company, as a technology. It's a great move for our industry because it means that some large firm with a metrology experience, with optics experience, with lithography experience is going to tackle the heavy lifting of making 3D printing and metal 3D printing a true production technology. And that's going to make everyone else run a lot faster, a lot harder. So I think it's very exciting news, and we don't know yet if the acquisition is going to go through, but it looks quite promising, and I'm all in favor for it. So I'm really, would want to know what you guys think about this as well. So let me know in the comments and stuff like that. And thank you very much for